Hi, this is Peter Kerr, and I want to welcome you to a quick session which shows how to use Tegile snapshots and clones to manage SQL Server databases. These are the two features which are most frequently requested as a demo for our existing and our potential customers. They can save tremendous amount of space on the array, meaning multiples make very good use of the DRAM and flash layers on our arrays, and they obviously streamline the workflow and provide additional capabilities to both the SQL Server DBA and to the storage administrator as well. This is Peter Kerr. I'm a Director of Strategic Alliances here at Tegile, and with me I have Harrison Waller, who will explain and do the actual demos once we go cover some of the theory. So what are the Tegile capabilities that we're going to talk about? You can create unlimited number of SQL Server consistent snapshots with no performance degradation, meaning the number of them won't degrade the performance of the array, and no loss of usable space in the array. This means no additional loss of usable space in the array. If I created 100 of the same SQL Server snapshots, they essentially would not take any new space. There would be some metadata that would be taking additional space. This is unique because of the architecture that Tegile has for DRAM and flash in both hybrid and all-flash array. This means that the original for the snapshots and the snapshots are actually served out of the same flash and DRAM space, saving you again money on investment or multiplying it multiple times if you want to think about it that way. The second claim and capability that Tegile makes is you can create read-write copies of production databases without wasting any space. And this only takes seconds. It takes no additional usable space out of the array. These are essentially free read-write copies. Once you start writing into them, only the deltas, only the changes are actually saved. So if you start with a 14 terabyte database, you are not copying over 14 terabytes of data. You are starting basically with 0 on the new copy, and only the new data that you write into it would be actually saved. And then no loss of performance, as long for the original database, for the production, or for any database that you originated this clone out of, as long as there are obviously IOPS available out of the pool, and there are IOPS available on the controller. So what are we going to talk about? So we're going to explain the technology Tegile uses to produce application-consistent snapshots and clones. And I stress application-consistent snapshots and clones, because not every company is able to provide this for you. And some of them will hide behind some acronyms and things like that. And then in the end, you find out that you can't do it. And the resulting pain for both the storage admin and the DBA is significant. We will demo SQL Server snapshots, and we will demo SQL Server clones for you. So before we jump into the technology that we use, I need to explain the application and VM consistency levels. So for virtual machine, no consistency means that the virtual machine is basically non-recoverable, meaning some or all of the files are missing middle, end, or they are not consistently taken, so you can't recover the virtual machine. Crash consistent means that the VM is recoverable, meaning the VM reboots and you lose all of the memory space that was actually held while the VM was running, and any application unsafe data. An example of that would be an Excel spreadsheet that I didn't save. When I take a snapshot of that VM and I reboot it, that spreadsheet is simply gone because I didn't have it, I didn't save it. And VM consistent, which means virtual machine can resume in the middle of the work where you actually left off. This functionality for the virtual machine consistency is provided by VAI on a VMware framework and by VSS, Volume Shadow Services, on the Microsoft framework. If you have virtualized on VMware, you need VAI. If you have virtualized on Microsoft Windows, on Windows Data Server, you need the array needs to provide the VSS framework. If they don't provide it, you cannot achieve these consistencies. SQL Server snapshot consistency levels are very similar. There is no consistency which means the database is non-recoverable, meaning the matching files do not exist or they are corrupted in some way. Crash consistent, which means the database, when you attach it to a SQL Server and you have all of the files, it still enters a restore mode and starts replaying all of the logs until it finds a consistent point. And this can take several minutes, but in many cases it can take several hours or several days. It is very complex. And that basically means that while you have a snapshot, it is really the last resort snapshot, meaning it's not something you can quickly go back to. It means that your production database may be down for hours or days. And then SQL Server consistent, which means the database will pick up where it left off immediately upon being attached to a SQL Server. The SQL Server consistent can only be delivered by the array integrating with the Volume Shadow Services framework. It doesn't matter that the array might have VAI. If it's a SQL Server running inside VMware virtual machine and you don't have VSS, the best that you will be able to do is you will get a crash consistent copy of the SQL Server, meaning the virtual machine might come up, but the data inside the SQL Server will be corrupted because you don't have this VSS framework. So this is the cascading thing. It's not one or the other. You have to have actually both if you virtualize SQL Server to get the right level of consistency. Okay, so what does this actually mean? How does it work? So Tegile uses something that we've developed called Tegile Data Protection Services, TDPS. And it starts by you as a system administrator, a storage administrator, or a DBA, starting a snapshot on the array. This will take a series of all of the data files, log files, multiple LUNs, however you have the database actually spread across the different drives or the different volumes, and it will request a VSS snapshot on the host from the VSS framework. This will actually instruct the writer, the Microsoft VSS, to prepare the snapshot for creation. And this VSS framework will now talk to SQL Server and many other applications on that Windows server to actually stop accepting requests which are not read-only, which require updates. And it will also instruct them to flush any information down to the actual disks. So it can create a checkpoint and you can create a application consistent snapshot. Then the writer instructs back the IntelliFlash array to actually create a snapshot. The snapshot is created. It's a group, an application consistent, meaning you can have multiple LUNs in that. And then the Microsoft VSS writer informs all of the applications that they can actually resume functioning as expected. And the application then resumes. In between step 4 and 6, it can take no more than 10 seconds. This is mandated by the Microsoft VSS. We do it significantly faster, but this is one of the conditions, so it has to happen very, very quickly. So the application isn't just sitting there waiting for the array to somehow figure out when to finish this snapshot. With that said, I will hand off the presentation off to Harrison Walker, who will walk us through the step-by-step both setting up and creating the application consistent snapshots, and then creating the read-write clones, which take no space, additional space on the array outside of the deltas, and make very effective use of the resources that are in the array, both DRAM and the flash. Imagine that you can take one database and you need to use it for development, QA, 2 reporting instances, and maybe test. So 5 copies, and the database is 14 terabytes. You know, you would need to use 55 or 60 terabytes of space, including your flash, including your DRAM, to actually provide that type of a performance to those people. With us, it will be purely the original space and only the deltas if you start writing into them. So without ado, I'll hand it off to Harrison Walker.
So I'm going to be showing you application consistent snapshot using the Tegile Data Protection Service and its integration with Microsoft VSS. I'll also show you a database recovery using the snapshot rollback feature. And then I'm also going to show you how you can use thin clones to copy an SQL database and present it to test, dev, or anyone else that wants to run reports on it or just play around inside the database without affecting the original database and without really a lot of space consumption on the IntelliFlash array. So let's pull up the foundation. Let me just kind of lay out what I've got here. Here's my Windows server, and here's my single DB that's loaded into there, and then let me go full screen on this remote desktop, and then down here is the data LUN, and then here's the log LUN, separating them so that we can get the right performance. And then, like I was going to say, the Tegile Data Protection Service is already installed on this Windows host, and it's registered properly on the IntelliFlash array. So let's look at what I've got on the array here. Let's go into my data and inside my pool. Here I've created a project, and you can see off to the right the two LUNs that I just showed you on the Windows host. And highlighting one of the things that Wen just mentioned on block setting, here's my data LUN, and you can see I've got kind of a generic database, so I went ahead and just set it to 64K. And then on the LUN side, it's set to 8K. So over here, these two LUNs you can see are inside a single project. That is creating a consistency group. So anything I do in there with snaps will be done at the same time. All the LUNs will be snapped at the same time, ensuring application consistency. So now, actually, before I do anything crazy on the database, let's take a snapshot. So let's go inside the project, go inside Snapshot, and let's take a baseline. So I'm just going to call this baseline. I'm going to turn quiescing on. That's what's going to talk with our TDPS agent on the Windows host, which in turn will talk to the VSS agent running on Microsoft on Windows. So let's just go ahead and create the snap. Now this can actually take from a few seconds up to, I've seen 30 seconds on hosts that are maybe not as decked out with RAM or memory or maybe busier. But while that's going on, it's probably already done, but let me just highlight over here in the Windows host, the event logs that are going on. Do a quick refresh. I've gotten kind of familiar with the event IDs, so I know I'm looking for event ID 1801. Let's see, 922. Oh, it is already. 1802 is done, but I do want to show you. Here's 1801. Here's where we're requesting the backup. It starts off, a number of other messages go through. Here you can see Microsoft has frozen the I/O, allowing us to do our snap. We just took the snap, and then, not to belabor the moment, here's event ID 1802, backup finished, 2 LUNs successfully snapped. So that's kind of what's going on the Windows host. So now back over here, let's just do a quick refresh. There's my baseline snap. So now we want to do some damage on the database. And let's have you guys participate in this fun here. I'm going to do a quick query on the database. It pulls up the first 200 rows, a bunch of names, IDs, some fake Latin over there. I don't know if you speak Latin, but focus on, I want everybody to pick a name and remember it. I've got my name. Everybody got your name? So let's just highlight all these rows here, and we're going to delete them. And once it's deleted, panic will set in. But no worry, we have a snap. Oh no, right? Not to worry. Let's do a recovery using the snapshot rollback. So the way I do it, and there's probably many ways to skin a cat, what I will do is just drop this database. And now I'm going to go back to the array and simply going in, here's my baseline snap. I'm simply going to click rollback. Yes. This is actually pretty quick. Done. Okay. Go back to the Windows host and let's reattach that database. It was in the E and the F drive. All you need is the MDF file here because SQL is smart and it knows, as you can see down at the bottom here, E and F, it knows exactly where the data in the LUN files were located. So all I got to do is click OK. Now, get rid of the old query, but let's do a new query on this table here. Yep, I see my name. You guys see your name?
Yep.
Little sleight of hand. No, that was real time, folks. So now, all of that was a snapshot recovery using rollback, but how do you know that was the snap you wanted to use? That you may have a number of snaps and you want to ensure that you're getting the right one to recover to. Well, actually, it's simple to go in and look at a number of different snaps, and that's using the thin clone feature where you can actually clone the LUN and the database that's on it, present it to your host as a separate LUN, and go in there and peruse and find out if that's actually the database snap point that has the data you're looking for. You could also use this to give it to test, engineering. You could run reports on it. Meanwhile, your original database is up and fine and untouched. So very simple here to do a clone. It's that little icon. Yes, I want to clone, and it's going to clone both LUNs. Just call it clone 1. This also is very quick. And done. Now when we do clones, we put this little C out front so you know that it's a clone. Let me just check real quick and ensure the mappings are right. Yep, LUN 2. And this should be LUN 3. It is good. So now let's go to the Windows host and do a quick rescan on the drives. There they are. Bring them online. And let's give them a drive letter. G works for me. And H for the logs. So there's your data and there's your log. Now, an interesting thing with Microsoft Windows is when the clone comes in, it's read-only. So you can see here, I can't create a new folder. I can't really do anything. You have to change it to read-write. And it's not through the typical properties security method. You actually have to use the disk partition utility. And I've got one fired up right here. And I'll just list the volume so you can kind of see what you would see. So G and H down here, those are the two new ones, the clones that I have. And if I just select volume 5, and then I do an attribute on the volumes in here, here's the thing that's stopping you from writing to it. And this is necessary when you attach the database inside SQL to be read-write, because it'll immediately write signatures and identify it. So it has to be read-write. So this is a simple fix, just clear, read-only. And now let's just do a glance again at the settings. There you can see it's now off. So now that LUN is read-write, and I'll just quickly do volume 6 and just make sure it looks good. And then over here, now I can create folders, change names. You can see it's read-write. Get rid of that folder. So now let's just bring it into SQL. We'll just go over here and we'll attach the database. We'll go out, it's on the G and H location. Don't have to worry about the name. What you're going to do right here is attach it as a different name. I'll just call it single DB2. One thing you want to be aware of is the file locations. I picked this so it populated that accordingly with the G drive. SQL remembers the original database and where it was located, so I need to ensure that the logs are matching properly here on the H drive. And that's it. And there you go. Now, you can run reports on it. You can go in there and look around if that has the missing data you were wondering. You can hand it off to dev, test. Meanwhile, your original DB is just fine. One other little piece I did want to highlight here is the fact that this didn't take up any additional space. The database isn't massive. It's about 7 gigs. And what I can do is just show you the dashboard. We've got about 574 gigs of original data. Let's just take a couple more quick clones, and I can show you how it doesn't affect your capacity consumption. We'll call this clone 2. And let's do a clone on that one. We'll call this, oops, that was a rollback. Clone 3. Let me do one more because I think I might have removed one of my clones. Call that clone 4. So now we got a bunch of clones flying around out there, a bunch of, you would think, extra data. Well, not really. See, look at all my clones. Let's go back to the dashboard. 574, it's still 574 of original data. So as you can see, it's linking to the original LUN, and only the changes will be made in those clones as you run reports, run test on it, run dev on it. So that's application consistent snapshots using the Tegile Data Protection Service. That's data recovery using snapshot rollback, and then thin clones allowing you to copy your database and present it to dev, test, run reports, or even do recovery. Thank you.
Well, thank you, Harrison. That completes our demo and presentation of how to make use of Tegile snapshots and clones, which are application consistent, use the VSS framework, and allow you to turn your organization into efficient machine as far as it comes to eliminating space for your duplicate databases and allowing you to quickly recover from failures and other situations. Thank you very much. Thank you for joining us.